Hello friends, welcome back to my YouTube channel. My name is Raghvendra and today I am going to explain you the bar bending schedule of a footing. So these are the some details I have taken here. Some details. These are the sectional elevation of a footing, and this is the sectional plan of the footing. The bar reinforcement is given over here, and also the detail. This is the bar along longer span, and this is the bar along shorter span. So details are given here. NB, this is a NB, and this is a NL. Okay, see here there is a footing F1. The size of footing is 3 meter by 3.2 meter. This is a capital D and small d. You can see here this is a capital D and this is the small d. Okay, this is the small d, and this is the reinforcement is given along shorter side 12 dia at the rate of 140 mm center to center, and along longer side 12 dia at the rate of 140 mm center to center. So on the both sides, I mean the shorter as well as the longer, the reinforcement is same, 12 dia at the rate of 140 center to center. So now let's come to this is the actual format of the bar bending schedule, which maybe you have seen in my previous videos, bar bending schedule of column as well as beam. And if you have not seen so far, so I am giving the link in the description box, so what you can watch there. And this is the sheet for the shapes. Actually you can prepare the shapes also here, but it's a very tedious job that you prepare the shapes in every row. So instead of making this, make a separate sheet, and when you get the printout of the bar bending schedule, so get the printout of this shapes also and staple it on the top of that bar bending schedule. So there is a coding also. This is a US, I mean the U shape bar. This is A, B, C, A plus B plus C. So like this, there is a shapes are there. So whatever the shapes will be utilized in this bar bending schedule only, that's okay, otherwise just delete these things. So this is the footing F1. The size is 3 into 3.2 meter. So along shorter span, the dia is 12. Number of bar, how you will calculate? 3.2, you can see there 3.2 divided by 0.14 and round off up to 0 plus 1. So this is a 24. Shape type is US. Just write over here shape type. This is very must, because without that you cannot find out what is the shape. And the reference for this US is this is a US, and the shape is like this. Okay, so this is a is 300. You can see that in the drawing. I am showing in the drawing what is A here. This is a D actually. So D and D. So there is a cover 50 mm in the footing. So 50 and 50. So 100 mm cover will be deleted. So deducted 0.3 minus 0.1. Okay, this is a B. What is B? This one is B. So B, how you get the B? 3 minus 0.1. There is a 3. The size is 3. Okay, and minus cover 50 mm both sides. So this is 2 point. And C, A and C will be same. 0.3 minus 0.1 and minus bending allowances. Bending, what is the bending allowance? 2 into 2 into 0.012. Bending allowances, with if you bend the bar, so it elongate. So that for these elongation we deduct it. Up to 10 dia we deduct 1D, and above 10 dia we deduct 2D. So to deduct the 2D into 2, both there is a 2 bends, 1 bend, and this is a 2 bend. This is a 1 bend, 2 bend. So for 2 bend, 2 into 2D, 2 into 0.012, 12 dia. So now you get the cutting length, this plus this minus bending allowances. Okay, number of sets. Number of sets means in that drawing how many F1 is there. Suppose that this is the, you can see the F1. So you just count it and write down. There is, in my drawing there is a 12 number of sets, so I'll write out 12. And now this is the total weight, unit weight as per IS 1786 1985. You can find out the unit weight from the d square upon 162.27 formula, but you cannot get the right value from this formula. So I recommend you take these values from the IS code 0.395, and this is the formula. It is very important formula you must learn. Is if this is a conditional formula actually. If C1 dollar is used to fix the row or column. If you place the dollar before this row, so the row will be fixed, and if you use dollar before column, so the column will be fixed. So this is the rule of this dollar. So dollar C11, this is a C11. Okay, C11 is equal to M8. Then again this is equal to this, then what happened, then this into this into this into this, it means this D11, which is D11, this number of bars into K11, this is the cutting length, into L11 is number of set, into M9 is unit weight. So just put this formula and drag this formula in the each and every row and column. So this formula will automatically placed in every row and the value will come. Okay. So along, now you can find out the along longer span. This is the tool. Now use the 3 along longer span. To find out the longer span, you have to use this span. This is a cutting length, but this is a span. So for this, for longer span, 3 divided by 0.14 comma 0, this is just to round off, plus 1. So this is a shape type is same US, and this is 0.2, this is 3.1. how it will come? 3.2 minus 0.1 cover, and A and C will be same, and this is the bending allowances, 2 into 0.012. And now you can get the cutting length, this plus this minus bending allowances. And now the number of sets will be same, 12, and you get the value over here. The same fashion you can find out the F2, F3, whatever is. If you want, I just this is 2.5 into 2.7. I'm just showing is F2 2.5 into 2.7. The D is same, 300. Okay, a small D is 300, and here the dia is 12 at the rate of 150 mm center to center. So this is the F2 details, and you can see in this Excel sheet, this is a F2 2.5 into 2.7, and in the same fashion you can find out this value also. This is the, you can say the 2.7 divided by 0.15, 150, there is a spacing of 150, so just divided 0.15 in, okay, plus 1. US, and this is the 2.4, 2.5 minus 0.1, the cover. In all these there is a cover minus, so you can find out there is a bending allowance deduction, and now you get the cutting, and again you get this. In the same fashion you can find out the value of F3. In the F3 you can see that there is in F3 there is a 16 die at the rate of 125 mm. So I am just showing here, and F3, just see that 3.7 divided by 0.125. okay, now the 16 dia, in the 16 dia the bending allowances will be 2 into 2 into 0.016. so this is the bending allowances. Again the value will come in the row, and just total all these things, just total it. Now you get the value in the kg. Convert it into the metric ton by dividing 1000. So you see that this is the 4.441 metric ton. You can also calculate other footings also. I am just giving the 3 footings over here just to explain here. Okay, and if you have any problem to understand, please write down in the comment box. I will definitely reply for that. And you can also download this format from the given link in the description box. I am giving the link of this Excel sheet in the description box, so you can download it from there. So thanks for watching.
Hello friends, please subscribe my channel and press the bell icon so you get notified for my every new video.